So hello, so today's problem of the day in the lead code is letter tile possibilities. Okay, so what the question is saying that we have given an n tiles. Okay, that is here the example tiles AAB, and we have to basically return the total number of possible non-empty sequences. Okay, so how many possible ways of non-empty sequences of this letter can be possible? So we have to return the number of that sequences. Okay, so let's understand this question much more deeply. Okay, so this is explanation. Like if let's example take a ABC as the string. Okay, let's take ABC. We have to generate all possible sequences of this ABC. I have generated this. These are the total possible generated possible sequences. Okay, so if we see that A, B, C, A, B, okay, you can simply arrange them. Total 15 are the possible unique solution, and we don't have to use a empty solution. Okay, so these are the non-empty. Total 15 solution can be formed. Okay, 15 possible sequences can be formed. Okay, so I have told you that whenever the word possible, total possible, or total possible sequences or total possible ways comes, we always have to use a recursion. Okay, we always have to use recursion for that, because recursion is a technique that generates all the possible ways for a particular thing. Okay, simply for here, like if this in this ABC example, to generate all the possible sequences, we would use recursion for generating it. Okay, simply recursion would take every possible decision for this ABC to and add the next letter and add the next letter, and it will generate all possible sequences. Okay, so how we are gonna do it? If I explain you the question more, then let's make a recursive table. Create the table. So here's the recursive table, how this whole table would be like. Okay, so for every possibility, so for every possibility we will have we will have for every sequence, like if for every digit or every sequence, we will have multiple we will have two possibilities, not multiple, that whether we have to choose it or not choose. Like for this first, in this ABC we have A. Okay, uh, and we have A, and we have two possibilities. Basically at first, if we see, we have basically three letters. Okay, three unique letters. So we will have three possibility, whether to start from A, whether to start from B, whether to start from C. If we start from A, okay, it will simply recursively check for it will simply start from A and recursively check for B and C with A. Okay, so with A we will have two possibilities, whether to choose B with A or C with A. Okay, so if it chooses A, B, then simply it will have only one possibility, that is choosing C, because C is left. Then simply it will generate ABC. Okay, ABC, and it will simply return to its previous recursive call, and it will simply return to its previous recursive call. Okay, basically if we see it, when ABC will be formed, it will simply return to this A, to AB, and then to A, and then again we will have the total. Basically A is not totally completed. Okay, so it will not return this time. Okay, it will simply for check for C also. Okay, then it will simply generate the sequence with C, that is AC, and then simply with AC it will simply generate ACB, and then after it will return to A. Okay, and then after it will return to this empty string, then we will have two choices, that is B and that is C. Okay, so simply this is how this recursive approach will work. It will simply check for every value, and every value will have two options, that is we have to pick or not pick. Okay, simply it is the type of a question famous question, that is pick or non-pick. Okay, it is a recursive approach, that is pick or non-pick. Okay, so at every position we will have choices, that whether we have to pick that letter or not pick that. Here we have three choices, that whether to pick A or B or C. So if we pick A, then simply this whole thing will got it. Okay, so this is the recursive approach. Okay, so if we take the example of this that we have given, first AAB. Okay, let's take AAB as example. Okay, if it has multiple same letters, then how will this work? Okay, let's change the values here. Okay, so I have changed the values for this. Okay, so here's the basically I have to check for AAB. Okay, so how this recursive call will look like for this? If we see there are multiple same numbers. Okay, if we see there are multiple same number, and so we don't have to choose that. Okay, so AAB or AAB, because there are two A, so simply it will create multiple same number. Okay, this AA or this AA is same. Okay, and this AA, this BAA, and this is BAA, and this BA are all same. Okay, so simply we have to choose only one. Okay, so that's why its possible ways are total 8, that here given. Okay, so this is how this approach, that is recursive approach, will look like. Okay, so let's go on the code. Simply I have written we will use recursive approach. Okay, so how this whole thing will work? Okay, let's see. Okay, so first we will use a set that will store the unique values. Okay, so that our multiple values couldn't be framed. Okay, so for first we are using a set, and then we will use a array. Okay, array of boolean function. Okay, so simply it will give true on that A, and it will simply first we will give false on all three, and then if we used in our basically code, then we will simply give true to every letter, so that it doesn't use okay again and again. We use the loop to basically we will loop the from 0 index to last index for every recursive call. Okay, so to prevent the use of A or use of B many times, so we will use a array, boolean array, that will store the true or false for the letter that it is used or not used. Okay, so if I write basically, if I give you the code, or if I write the pseudo code, or okay, so here's the code basically for I have written the code. Basically it's a pseudo code only for loop. I will tell you the whole code in the LeetCode. Okay, so let's check how this is working. This is in the basically the in the recursive call. Okay, so this is basically what we'll do is this code will be, it will check for every time from starting for the tile. Okay, like if we take the example for tile number ABC. Okay, simply it will iterate through int I equals to 0. Okay, it will start from here, from A. Okay, if I write here I, okay, I from A. Okay, it will simply check, it will check if the is the digit or basically the letter is used or not. Simply it will give it will, if the answer is true, then simply it will not be in this loop, it will simply move to next. If the answer is false, it will simply true this element. Okay, it will simply true the index that is basically on for A, and it will simply call generate sequences again. Okay, that is basically recursive call. It will simply call generate sequences, and it will simply give tile for what the generate sequence will be called. It will simply call for generate current. Current is the current basically sequence. Basically what I have given, current is now empty. Okay, first we will give empty string. Okay, the current is now empty, so simply it will add it to the it will simply add it to the tiles I. So the new current would be like this. Okay, so it will simply, we can write this. Okay, so the new current would be like this. So it will simply generate sequence, will simply call this for A. Okay, this new current. Okay, and we will simply give set. Okay, I have written this set 2 times. Basically this is a array. Okay, this is the array. So it will simply
generate the sequence for next, that is next current, that is basically A. Again, this loop will be called, we will simply what we will do is we will simply insert every time, okay, set dot insert every time this current, okay, we will simply insert every time this current for previously, basically before reaching this loop, okay. So again we will simply check for int I equals to 0, okay, I equal to 0 is A, okay. It's the basically if the array of basically this A is true, then simply we have to move forward. This time A is true because we have just used the A, okay. So A is true, then simply it will move to again, okay. It will simply move for I equals to 1, that is B. It will simply check if the array of basically if the B is false or not. The B is false because we have not used B. It will simply move to the B, okay. This I will move to B, okay, and it will simply add this current. It will simply add to this current and it will simply generate again for next sequence, okay. Simply it will become AB, okay. So the new sequence would be for AB, and then again we will come in this basically generate sequences recursive call, okay. For again at the third time for this it will call again, okay, and we will insert the same thing in set to basically to check the repeated things are not there, okay. So here's the no repeated thing is going to form, so simply we can ignore this. We just have to focus on this loop, okay. So next we will check for 0 index, it is A, it is simply true this time, and it will simply check for again 1 index, it will simply it is also true this time, okay. And then it will come to C, it will check, and this time the C is false, okay. So it will simply add it the C also and add the C also, and it will simply generate A B C sequence, okay. It will simply generate A B C sequence and it will simply form this, okay. And at last then again the current will be new ABC, okay. It will simply come to this loop again, okay, and this time this loop will exit, okay. This is basically the base case, okay. If the basically string is completed, it will simply exit the loop and the basically recursive call will be cancelled, because what will do basically it will simply come here I is equal to 0, it will check for A, it is not there, basically it is not basically false. It will simply check for next for B, it will simply say it is true, and then we'll check for C, it is also true. Then it will simply go on the third case, that is array I. It will simply basically exit the loop, not this time, okay. It will exit the loop and give to it and go to its previous call. If I write total how many calls we have made for function, for first, that is we have empty string given, okay, and then we have called this, let's make it, okay. For function, return all the functions that we have called. Simply for first we will call the when we will say that current is empty string, then it will simply call for function of A, that will be this current is updated, and for AB for ABC. At last this function, when this function will reach, then simply the basically it will not be in this loop, it will not come in this if condition, and it will simply exit the loop, okay. And so this function will return, okay. The recursive call will start return, okay. So what will happen? It will simply return for, let's make it, okay. It will simply return to this, okay. So this function is going to void, so simply it will not return any value, okay. So it will return to this, and then simply it will, this function will also terminate, and this function will return to this, okay, function of A. And this time it will simply again call the function for what let's say it will simply again call for the function that is basically function of AC, okay. Now same thing will repeat. It will simply make what it will simply make, it will simply make a function of ACB, okay. So this is how whole thing is working, okay. So you got the thing that how this recursive call will work, okay. Simply it will make ACB, okay. Simply it will then again repeat, and it will simply come to this, okay. Let's just make first one iteration. It will simply come to this, and this will give to this, because A is all possibility are, we have just make the all possibility for A. It will simply return to this function empty string, and then it will go for B, and then it will go for C. The whole thing will how this work, okay. So let's just what this array of I equals to false doing, okay. Simply it is for backtracking. Let's just check what this will do, okay. Why we are making false again? So simply when this if we see this first basically for ABC, it will simply, when this will come, okay, this ABC will return AB as a, okay, it will return void function, okay. When this will be on function of AB, simply this function has executed, okay. For this function of AB, it will simply go on this array of I, okay. For this function of AB, this function generate sequences executed, okay. It has simply returned void, okay, and it will simply go on this array of I, okay. It will simply come on this and this time, and the array of I would be on what? On B. it will simply make b as false again. So why b as false again? Basically it will make b as false because for next time when we come for b, okay, when this whole thing will be like in this, if we see this function of acb, if b is not false, then it will simply if I don't write this condition, then for this acb, that here b is added. Why b is added? Because b would be false. So that's why we have added here false, that it should make again false if we have come backtrack it. Okay, if we have come backtrack, then we have to make that digit again false, so that we can use it for again the for making the sequences. Okay, it is so simply it will make the sequences false again and again. So this is how this recursive approach will work. Okay, so this is the approach. So we can make we can optimize this recursion using something else. Okay, I will not explain in this detail. I will simply explain how can we basically optimize this solution. So the next, if we see the solution, the optimize the recursion. Okay, optimized recursion. Simply what we will do is, let's just explain the question. Okay, why are we optimizing this recursion? Okay, simply if we see that if we have given this condition AAA double B C, we have been basically if we assume that we have many test cases in which a single letter is repeated many times, simply it will call again and again for that single letter. Okay, so to avoid this, to not check for every letter, we can simply check for frequency of the letter. Okay, it will simply if we see that here are three basically what 3a, we will simply check for every, not for every a, we will simply check for frequency of a. Okay, simply for b, it will simply check for 2b. Okay, so to avoid for every letter, we will check for every frequency. That is, we will have only 3 letters a, b, c, and for a it is 3, b for 2, and c. So simply we will optimize this solution using an array that stores the frequency of every element. How this array would be like? This array would be simple. Okay, of 26 total elements, that we will store simply 0 at first. Okay, so we will store 0 at first, and then simply we will calculate the total frequency of, like if we see for this a would be 3, b would be 2, and c would be 1. We will simply calculate this whole frequency for this array. It will simply a is basically for index 1 or index 0. It will simply iterate on the indexes. Okay, we will simply, I will tell you how this is going to, okay, in the code. So simply this will calculate this and calculate the frequency, and we will simply recurse using the frequency this time. Okay, what we will do is, so here's the basically the code for this approach. If we see I have taken the basically loop, okay, not the whole pseudocode. We will simply check for this loop. Okay, this is the main loop that will simply iterate the value. Okay, simply what this loop is doing, it will simply check. Okay, it will simply check if the current this array, character count array, okay, it will simply store the character count. It will check if the basically character count array basically on that position, if the 0 is stored. Okay, if the 0 is stored, okay, same as the previous approach, it will simply check in previous approach we are checking that for it is there any false or true for. Okay, simply it will check is if the character count, okay, if there is no element, then it will simply, we will say continue. Okay, continue the loop. And if the character is not equals 0, if the current character is present, like in this 3, a is present 3 times, it will simply add the value in total count. Total count is the number that we are going to return. Okay, it will simply add the value to the total count, and the total count would be 1. Okay, and if we see character count, okay, we will simply minus the character count because we have used the character count, and it is simply we will use recursive approach to find the total count value. Okay, same the previous approach. Okay, and we will at last plus again the character count. Why we will plus? In the same we have used here, that we will at last we will make the position as false. Okay, that was previous, and we will simply make the character count as plus plus, because we when we backtrack the value, if we don't plus plus, then it will not used for another sequence. Okay, okay, it will simply be ignored. Okay, so for this we can use character count, and we will simply plus plus. Okay, to this, and this total count will simply give to the total count of the whole sequences. Okay, that we have not used set here. Okay, why we are not using set? Basically we are not using set because in this we are working on the unique sequence itself. Okay, we are iterating for the for basically that frequency. Okay, for frequency, not every digit, every letter. Okay, so simply we just need not to use hash set. Okay, or set. Simply we can use character count for this. Okay, so this is the whole approach. I will take you the code for both the code. I will so this is the whole approach. I will provide you the both the code, that is this recursion, previous recursion, and this optimized recursion. Okay, and I will explain you the code also. Okay, this recursion I have not explained because I have explained this. Okay, so this is same. Okay, this is simply same, and it is simply just we are using the frequency. Okay, so here's the
Basically the code. Okay, in LeetCode. Okay, so I have written the whole approach. That is, it is the first approach, and it is the second, basically optimized recursion. Let's check. Okay, so if I just comment out just comment out this. Okay, let's just work. So let's check. First I have declared the set, this is sequences, and we will using a bool array that will simply store true or false for the basically character. Okay, and we are calling generate sequences, and let's check generate sequences, then I will explain later. They just see generate sequences. Okay, we have taken tiles. Okay, the string that is given, and the current where the tile is now, that is basically empty string, and the array, bool array, and the set. Okay, so we are simply inserting first. Okay, we are simply inserting first, and then simply we will check in whole tile that if not array of I, basically if the value is false, then simply we will make it true, and then recursively check for the sequences. Okay, possible sequences, and then at last when we backtrack, we will simply make it false so that we can use it further. Okay, so after this whole function, it will simply come to this again, and it will simply return sequences dot size -1. Why -1? It will simply return the size of the set. Okay, why -1? Because -1 because for that empty string. Okay, we are providing this empty string. It will simply also be added. Okay, so we don't have to return the empty string also. Okay, so it has written that we have to use only non empty subsequences. So simply it will we have to just -1. Okay, because we are removing that. For next, this is the approach. Okay, we are simply taking the character count of total 26 spaces, that is basically array, with 0. Okay, initially, and then simply are using this loop there, where we can simply we are using the updating the frequency of every element. Okay, simply character count tiles I, that is character, minus of this ASCII value of this character, it will simply update on that position. Okay, then we are simply returning. Okay, this find sequence function, that will simply give us total number of sequences. What this function is, we are simply taking a total variable that will calculate the total of the total sequences, and we simply check. We are simply iterating through the loop till whole array, basically this character count. Okay, if the character count at the index is 0, then simply we are continue, we are using we are continuing. And if it is not, then simply we will check, we will total plus plus. Okay, we will simply total, add the total, basically. If it is not, the character count is not 0, we will simply add it to total, and then simply subtract the frequency, and then simply we are recursively calling the find sequence function. It will simply find the total possible sequences, and then simply we will again add the frequency. We will basically update the frequency to previous, okay, so that it can use again for possible sequences, and then simply we will return total, and it will simply return total from this function, and it will simply give the total number of possible sequences. You can run both. Okay, so simply if we run this function first, it will simply give let's check. Okay, it is giving 43 ms, that is beats 33%. If we comment out this and run second, okay, so let's check. And if we run out, then simply it's better than that. Okay, you can simply see time complexity also here. It's big of 26 factorial, that is basically second version is 2 to the power something. Recursive approaches are all these. Okay, they are so much time complexity. Okay, so this was the question. Okay, so hope you liked it. Please subscribe the channel. Okay.